Hopefully this next unit should seem familiar to a lot of you, and you'll have to excuse me. It sounds like I'm apparently going to be losing my voice here soon, so we're going to do two different units on polynomials. The first one is writing equations, drawing the graphs, end behavior, things like that, and then we'll do a different unit on solving polynomials. So the first question is, what makes a polynomial? So a polynomial is a string of different terms that are all added together. Remember, technically subtraction is also addition. But it seems really strange. There's two little n's with this first term. This first n right here is just telling you that it's the coefficient that goes with the x to the power of n term. So this little n minus 1 right here is just telling you that it's the coefficient that goes with the n minus 1 power term, because the coefficients aren't what's important when deciding if it's a polynomial. This definition right here for n being a non-negative integer, it's mostly pertaining to this x to the power of n right here. I mean, it's also true that n has to be a non-negative integer for the coefficients, because you're talking about the coefficient for the first term, coefficient for the second term, coefficient for the third term, that kind of thing. But they tend to go in a different order. So really all we're talking about, this definition says, to be a polynomial, the exponent n has to be a non-negative integer. Doesn't sound like much, but there's two key words in here that are incredibly important. Right here. Non-negative and integer, and they mean two completely different things. So let's talk about what number one means, what non-negative means. If n, the exponent, was allowed to be a negative number, then what would happen? So for example, if I jump over here, if I did x to the negative 1, it would become 1 over x. If I did x to the negative 2, it becomes 1 over x squared. So the fact that the exponent has to be non-negative means that there are no variables in a denominator. Now you've got to be careful, because there can be denominators in equations, but you just can't have a variable in them. And you'll see those throughout this unit. And then the second stipulation is that the exponent has to be an integer. So then that leads you to question, well, what would happen if it wasn't an integer? What kind of numbers are not integers? And the numbers that are not integers, whether they're decimal or fraction, they can be written as fractions. So let's see what happens if I have a fractional exponent. If I had x to the 1/2, some of you may know already that that's the same thing as the square root of x. If I had x to the 1/3, it would be the cube root of x. So the fact that the exponent has to be an integer means that there can be no variables in a radical. As long as you don't have a variable in a denominator or a variable in a radical, then it's a polynomial. Okay, so I've already talked about these right here. These are the guys attached to the front of each of the terms, so they're called the coefficients. And you always want to write your polynomials in standard form. One of the things we're going to be talking about here in the next few days is the graphical behavior of these things, and they're controlled by the term that will be in the front when your equation is in standard form. So standard form just means that you're going to put it in order from highest exponent to lowest exponent. Once you've done that, the term that's out in front of the equation is the one with the highest power. And since it leads the equation, we call it the leading term. I usually abbreviate that LT. Don't want to have to write it out over and over and over again. The coefficient attached to that term would be the coefficient attached to the leading term. So of course, we call it the leading coefficient. Pretty self-explanatory. And of course that means that I usually abbreviate it LC. And the power that's in that term gives you the degree of the polynomial. So it's going to tell you a wide variety of things about that polynomial. That leading term is incredibly important, which is why we wanted to lead our equation. Now you guys have actually already studied a lot of these. You did, I can't even imagine how many units you did in Algebra 1 and Geometry and Algebra 2 on linear equations. Those are polynomials with a degree of 1. And it sounds really weird, but think about slope-intercept form. Slope-intercept form is the polynomial standard form for a line, because this term right here has a power of 1, and this term right here has a power of 0. It's got no variable in it at all. So it's in descending order by exponent. You guys also did multiple units in Algebra 1 and Algebra 2 on quadratics. And you know what that standard form is, ax squared plus bx plus c. Same thing, it's in descending order by exponent. So we're going to be dealing predominantly with cubics and quartics. We are going to go all the way up through quintic in pre-cal, but most of the stuff we do is cubic and quartic. As far as the graphing and the characteristics of the graph and things like that. So the first thing I want you to do is pause for just a second, and I want you to look at these two polynomials. I want you to make sure they're in standard form, and then I want you to figure out what the leading term, the leading coefficient, and the degree are going to be, because that's one of the first and most important things. Okay, hopefully you paused it like I asked you to. And then, as you looked at number 1, hopefully you figured out that number 1 was not in standard form. It doesn't require a ton of rearranging, but the 2x to the 5th is the term with the highest power, so it needs to move to the front. And then it would be the minus 3x cubed minus 7x plus 2. And so that means that the leading term of your polynomial is the whole first term, 2x to the 5th. And the two important parts of that term would be the leading coefficient, which is positive 2, and the degree, which is 5. And then the second question was already in standard form, so you can just go straight to the answers. The leading term of that is the whole 4x to the 7th. The leading coefficient is 4, and the degree is 7. Okay, so nice and easy so far, right? So now, pause again. This is just a yes/no. Which of these do you think are polynomials? Okay, hopefully you paused again. And it should just be a first glance gut instinct kind of thing. So hopefully everybody said yes, this was a polynomial. Hopefully everybody said no, this was not. On the quiz, it's going to look like these fill in the blanks down below here. So you might want to make sure you understand that it's because there's a variable in the denominator. The one that tends to be up for debate is number 1. Some people say no, and some people say yes. Actually, usually the majority of people say no, but the answer is actually yes. This is a polynomial for a variety of reasons. First of all, it's linear. Secondly, the reason that there's no variable in it at all is because it's x to the power of 0. And remember, the only two requirements are that you have non-negative integer exponents. Well, 0 is a non-negative integer. So yes, it is a polynomial. Once you've decided whether or not something's a polynomial, then you can tell whether or not it's got any undefined values. Polynomials don't have any. If If you think about your basic linear function, or if you think about your parent quadratic, or if you think about your parent cubic, or any of those, there are no domain restrictions to it. There's no holes in the graph, there's no vertical asymptotes in the graph. The domain is all real numbers. So polynomials automatically have no undefined values. So as soon as you look at a cubic function like this first example, and you say, yes, it is a polynomial, then the first thing you could do is say, well, that's not applicable. I'm not going to answer that. And you can also say there are no undefined values. Okay, make sure that you don't ever leave anything blank, because blank to a math teacher means you didn't know what to put there. Okay? And then when we ask you to find the zeros, we're asking you to take your equation and set it equal to 0. So x cubed minus 9x is equal to 0. And we're not going to be doing the hard solving right now. We're just going to do the ones that you can factor easily, or you can just rearrange to solve. So like this one, if I pull out an x, it leaves me with x squared minus 9. And I can either solve it in its current form, or I could factor it even more, because x squared minus 9 factors as x plus 3 and x minus 3. So nothing too difficult. We've got a cubic. We've now got 3 factors, which means we're going to have 3 answers. First factor is 0. Second factor gives us negative 3, and the third factor gives us positive 3. There's my 3 solutions. Okay? So now I want you to figure out as many of the blanks here as you can. So pause again, and then come back in just a minute when you're ready, and we'll go from there. Okay, let's see what you've got filled in so far. So, is this a polynomial? No. Once again, this one has a variable in the denominator. Okay? And so then you ask yourself this question. You always want to get the undefined values out of the way first. So this is a big fraction. What makes fractions undefined? Okay. Hopefully you're thinking to yourself, or you're saying out loud, that fractions are only undefined when there's a 0 in the denominator. So what that means is if you want the undefined values, because this is a fractional equation, all you need to worry about is when would this denominator be equal to 0? And it would be equal to 0 at negative 4. So negative 4 is the undefined value for that equation. Then you can take care of the zeros. And the reason you want to do this one first is because let's say that I gave you an equation like x squared plus 4x over x plus 4. Well, that equation would simplify. And so what would happen is that people would list the negative 4 for the denominator to make it undefined, but they would also list it for the numerator. Well, think about that. If you plug negative 4 into the top and the bottom, that doesn't mean that your equation is equal to undefined and it's equal to 0. It's not possible. Once you've decided that a certain number makes your equation undefined, it can't be listed anywhere else. So you should never list it here as well. So that's why you want to take care of this one first. Okay? Now that's not the case for this particular problem, but it's just something to keep in mind, because usually I don't give you examples for no reason. So the zeros, there's 2 ways of doing it. You can take the whole equation. Let me make some more room. You can take the whole equation and you can set it equal to 0, and that's fine. The first thing that you would do is you would take that denominator and multiply it up to the other side, and it's going to go away anyway. But you could also just take the numerator and set it equal to 0, because fractions are undefined when there's a 0 on bottom, but fractions are 0 when there's a 0 on top. So you're really only worried about when the numerator is 0. And so this one, I'm going to just solve my numerator. So once again, I'm going to need to make some more room. I have big handwriting, and so I'm going to take my numerator and set it equal to 0. And I'm going to factor out x, just like I did on the previous problem. But this time around, I'm left with a quadratic that doesn't factor anymore. And that's perfectly okay. Because when you have any equation that you factored as far as you can, you simply take each factor and set it equal to 0 and solve. So I've already got my first solution right there. But I would need you guys to practice solving that. It's a number that should look familiar after you've gotten it done all the way. So once again, pause it. Try and solve for x, for that factor, really quick. Okay, hopefully you paused it. And let's see how far you were able to take it. So hopefully, first you added the 1. Then you, of course, divided by 2. And then hopefully you square rooted. And you remembered plus or minus, hopefully. And you got the square root of 1 over 2. So for those of you who remember, square rooting a fraction means square root the top and square root the bottom. But of course you couldn't have left it like that. This should be beginning to look familiar. So you would rationalize it and it would become this, which is one of the numbers we saw all of last semester through trig. So those are your other two solutions. Plus or minus square root of 2 over 2 are the other two solutions to that rational function. And then the final example for today, is this a polynomial? No. Why not? Remember, don't just say there's a radical. What is it that's inside of the radical? So hopefully you remember to put that there's a variable in a radical. That's what makes it not a polynomial. So then once again, if you want to go for the undefined values, then you have to ask yourself, okay, if it's not a polynomial, what kind of equation is this? This is a square root equation. And there's only one thing that makes square roots undefined, and that's when the number inside the square root is negative. So you have to figure out where that's going to happen. So take what's inside of the square root, which is just the 2x, and figure out where it's less than 0. And so this time around, your undefined values are an entire interval. Every x value less than 0 would make the number inside the square root less than 0, and so you would have imaginary answers. So that's what makes it undefined. And then finding the 0 means just take the equation and set it equal to 0. You're solving these things. Add the 9 to move it over. Square both sides to get rid of the square root. And then divide by 2. So there's my one and only solution. And if you want to write that as a decimal, that's fine. It's exact. Doesn't require rounding. Okay? So that's it for today. We're going to do the remaining 4 problems on the notes tomorrow. Mostly as like our warm-up. So I hope you're feeling okay about polynomials so far. Come see me if you have any questions.